In section 8.5, we're looking at the difference between two populations. We're testing for difference there. We could do that for the mean or a proportion. Number 10 is a proportion question. We see that we have one sample, N1 is 210, and R1, or the number that have the characteristic we're looking at, is 61, and another sample of 189 for the second sample has a number of positive responses of 45. So we're looking for a difference either way between the population proportions. The level of significance is stated there always in the problem, or determined first by the researcher. Then we have to determine the hypotheses. The null hypothesis will always have equals, so we can throw out the second choice. And then we have to determine the alternate hypothesis. This one is two-tailed because we're looking for a difference in either direction. To decide the sampling distribution, that depends on two things: if we're doing proportions or means. In this case, we're doing proportions, so we don't have to ask the second question, which is whether we have the population standard deviation or not. Since we're doing proportions, we have a standard normal distribution, and then we have to calculate the value of the sample test statistic. The easiest way to do this, of course, is on the calculator right away, where we just put in the numbers and let it do the work. So I'm going to do that first. And we'll go to Stat, scroll over to Tests, and we have a 2 proportion z-test, number 6. The number of individuals with a response of yes in the first sample is 61. The number of individuals in the sample is 210. The second sample was 45. And the sample size was 189. We're testing a two-tailed test. We want to know if it's different. The first proportion is different than the second proportion. So we press calculate. Our alternative hypothesis is here, restated for us. Z is the test statistic, 1.8 or 1.182806. It says we need 2 decimal places, so I will give them 1.18. The p-value is the next line. This is p, and then p hat were the sample proportions from the first and second samples, so the p-value of this test statistic is 0.2369 to 4 decimal places. That 8 looks to the right, and the 8 is big, so that one becomes 9. Remember, it's a two-tailed test. So we're testing either direction. That means our picture will look two-tailed. The other 3 do not, so this guy's our only option. And then we have to make a decision. Are they statistically significant at alpha? If the p-value is less than alpha, then we are statistically significant. That means it's so unlikely, or our p-value is low enough that it's less than our level of significance, and we are willing to reject. Our p-value was 0.2369. You can compare that to 0.1, the level of significance. We'll see that p is not less than alpha. This means that 23 or 24% of the time we will get this test statistic, 1.18, under the assumption that there's no difference in the sample proportions. So we are going to fail to reject at alpha equals 0.10, fail to reject because the data are not statistically significant. To make an interpretation of this, we have failed to reject. There was insufficient evidence that the proportion of women favoring more tax dollars for the arts is different than the proportion of men. We ran a sample on both populations. We read a test on the difference between those two samples and did not find a statistically significant difference.